This week in CIST 2612, we'll look at Chapter 12, which will cover mobile device forensics and the Internet of Anything. Now, in this chapter, we're going to look at the basic concepts of mobile device forensics and the procedures for acquiring data from the mobile devices. We'll also look at the challenges of forensic acquisition of data that is stored on the Internet of Anything devices. People will store a wealth of information on their cell phones, but not many people think about securing their cell phones. There is a lot of information stored on cell phones, such as your incoming, outgoing, and missed calls, your text messages, email accounts, your messaging logs, web pages you have visited, pictures, video, music files, your calendars and address books, social media account information, GPS data, voice recording and voicemails, your bank account logins, and also maybe access to your home. So because of all of this information that's stored on mobile devices, a search warrant will be needed to examine those mobile devices. Now, also investigating smartphones and mobile devices is one of the most challenging tasks in digital forensics, simply because there is no single standard that exists for how or where the phone will store the messages, and also because of the emerging technologies. So new phones will come out about every 6 months, and a lot of times they're rarely compatible with previous models. Also, phone technology has rapidly advanced. We've got 5 generations of mobile phones. So by the end of 2008, mobile phones had already gone through 3 generations. You had analog, the digital personal communications service, and the 3G, the 3rd generation. Then 4G, the 4th generation, 4G came out in 2009. Now we are into the 5th generation of cell phone networks, 5G. This was something that was finalized in 2020. It incorporated emerging technologies, which also included the ever-expanding cloud and device-to-device networks. Most code division multiple access, or CDMA networks, they will confirm to an IS-95, which that's a widely used digital cell phone technology that makes use of spread spectrum modulation to spread the signal across a wide range of frequencies. The Global System for Mobile Communications, the GSM, that's a 2nd generation cell network standard. This is something that's currently the most popular cell network type in the world. It uses the time division multiple access technique, which is where multiple phones take turns sharing a channel. The 3G standard was developed by the International Telecommunications Union. It was under the United Nations. It's an international organization, and when it was done, it was dedicated to creating the telecommunications standards. The 3G is compatible with CDMA, GSM, and TDMA, and then they had the EDGE, the Enhanced Data GSM Environment standard that was developed specifically for the 3G, and that was an improvement on the GSM technology. And then what it does is it allowed them to deliver higher data rates. Now, 4G networks, it can also use these technologies you see here, like, for example, the OFDM. That uses numerous parallel carriers instead of a single broad carrier. What it does, it makes it less susceptible to interference. Now, our main components for Communications include a base transceiver station, a base station controller, and a mobile switching center. So when we look inside mobile devices can range from simple phones to smartphones, tablets, smartwatches. Each one of these is going to be made up of the cell phone hardware. It's going to have a microprocessor, ROM, RAM, a digital signal processor, radio module, microphone and speaker, hardware interfaces, and the LCD display. Now, your basic phones are going to have proprietary OS, most of them. Smartphones are going to use the same operating system as PCs. The phone stores system data in electronically erasable programmable read-only memory. This does it enable service providers to reprogram phones without having to physically access memory chips. In this case, the operating system is going to be stored in ROM, which is a non-volatile memory, so it's something that's available even if the phone loses power. Now, PDAs, or personal digital assistants, these are something that's mostly replaced by either iPods, iPads, other mobile devices. So they have shifted, their use has shifted more to specific markets, such as something in the medical or industrial. And they do have peripheral memory cards that can be used with PDAs, including compact flash, the multimedia card, or secure digital cards, the SD cards. Now, SIM cards, they are something that we found most commonly in GSM devices. They consist of a microprocessor and internal memory. The GSM, it refers to mobile phones as mobile stations, and it divides the station into two parts. You have a SIM card and you have the mobile equipment, the ME. Now, keep in mind that SIM cards come in 3 sizes, and the portability of information make that SIM cards very versatile. With SIM cards, also older CDMA phones, they won't use SIM cards. What they do is they incorporate the card's functions into the phone. Now, the newer TDMA phones in North America, they do use SIM cards, but they are sealed, so the user must contact the provider when changing phones, or providers with those type of cards. There are some additional benefits, though, for using SIM cards, or additional purposes of those. They identify the subscriber to the network. They store service-related information, and they also can be used to back up the device. Now, a lot of phones now also include a SD card for external storage as well. When we look at the acquisition procedures for mobile devices, the main concern is the mobile device losing power, or whether or not it's synchronized with the cloud services, or if it can be remotely wiped. Now, all mobile devices, they have volatile memory, so you make sure they don't lose power, so you can retrieve the RAM data. That is a critical step, because once the power is lost, the RAM loses the data that is stored in there. It is wiped. Now, if you find a mobile device that's going to be connected to a PC through a USB cable, that should be disconnected from the PC immediately, because that helps prevent the synchronization that might occur automatically and overwrite data. Also, depending on the warrant or subpoena you have issued, the time of the seizure might be relevant. Messages might be received on that mobile device after the seizure. From that, you must isolate the device from incoming signals, and you can have one of these options you can use. You can place the device in airplane mode. You can place the device in a paint can. You can place it in a Faraday bag, or you can just turn the device off. Remember though, if you turn the device off, you could lose the information that's stored in the RAM, vault of memory. Now, one of the drawbacks of using these isolating options is the mobile device is put into roaming mode, which accelerates the battery drainage. So, a couple things that are recommended from the SANS DFIR forensics. They recommended that a device is on and unlocked. You want to isolate it from the network, disable the lock screen, and remove the passcode. Now, if the device is on and locked, it's going to depend on what type of device you have to what kind of what you can do. If the device is turned off, you want to physically attempt a physical static acquisition and turn on the device. So once you get the device and you get back to your forensic lab, the areas that you want to check include the internal memory, the SIM card, any removable or external memory cards, and also with the network provider. Now, checking them for the provider, their servers, that's going to require a search warrant or subpoena. So that's another complication that has arisen is the fact that the backups might be stored in a cloud provider, cloud service that's provided by the carrier, or it may be something that's provided by a third party. So you would need another search warrant or subpoena to gather that information. Now, with the growing problem of the phone being stolen, mobile devices being stolen, service providers, they have started using the remote wiping to remove personal information that was stored on that stolen device. So that is another issue that you want to make sure it is something you take in consideration. Also, that memory storage of mobile devices is usually a combination of volatile and non-volatile memory, and that the file system on a SIM card is in a hierarchical structure, as we can see in the example here. Okay, so in this case, we have a hierarchical structure for our file system. Now, the information that can be retrieved would fall into 4 categories. We have service-related data. This is the identifiers such as the SIM card and the subscriber. The call data, that's the numbers that has been dialed. Then you have like the message information and also the location information. Keep in mind though, if power has been lost to this phone, this mobile device, the PIN or other access codes might be required to view the files. So you will need to unlock the phone. The mobile forensics, this is an evolving science, so it leads to a lot of challenges. The biggest challenge is dealing with constantly changing phone models. So we do have some procedures that we use for working with mobile forensic software. We need to first identify the mobile device. We need to make sure you've installed the mobile device software on your forensic workstation. Attach the phone to its power supply and connect the correct tables. And after you connected the device, you want to start the forensic software and then begin downloading the available information. Now, a SIM card reader is a combination of hardware software devices that's used to access the SIM card. Um, you want to be inside of a forensics lab with the appropriate anti-static devices. And for this, our general procedures for reading a SIM is remove the device back panel, remove the battery, remove the SIM card from the holder, and then insert the SIM card into a card reader. You may have an adapter for the SIM card that you need to place it in first, depending on the type of reader you have and the size of the SIM card. The SIM card readers, there's a variety of SIM card readers that are available. Some of those are forensically sound, some are not. You want to make sure that one of the critical things is that document the messages that have not been read. That's critical. With this, you would use a tool that takes pictures of each screen, so that can be something to be valuable in this situation. Now, a couple of mobile forensic tools and methods that we have available include Access Data, FTK Imager, maybe Mac Lockpick 3.0. The NIST's got 6 types of mobile forensics methods listed here. They have the manual extraction, logical extraction, physical extraction, hex dumping and joint test action group extraction, chip off, and micro read. So those are the 6 types of mobile forensic methods that are available or recommended by the NIST. Now there are some other tools available. We see some here listed on the screen and what they are used for. A couple things to keep in mind is that our software tools that would differ in information display and the level of detail. Some tools are designed for updating files, not retrieving data. If the tools in general are designed to edit information, they're not forensically sound. They may be a little bit more user-friendly. Also keep in mind that this software is not something that's really cheap. Now, every program is going to have some kind of shortcoming or something that you may not, it may not do every task that you are looking for. So you want to make sure that whatever tool you use, you document each step that you take during the investigation. Celebrite, that's something that's often used by law enforcement. A couple things you can do with this is determine the device's make and model, learn what has been done before connecting the mobile device to the UFED device, and then retrieve the data. You can also simply connect the mobile device to a computer and browse the file system and examine and retrieve files. So we're going to look at the file system on an Android connected device to a USB system or a USB cable to a computer. Now, if you need to make an acquisition here, you need to put a USB write blocker in. This is something that's using this technique is not going to be ideal, but you can use it to gather basic information. Now, keep in mind also that there are many different types of forensic tools for the mobile devices, mobile forensic tools that are available. Most of them aren't free. Most of them are very expensive. And also these methods and techniques for acquiring the evidence, they change as the market continues to expand. So One of the suggestions is to keep in the loop and keep up to date is subscribe to user groups and professional organizations to find out what's happening in the industry. Okay, so we look at forensics in the Internet of Anythings. We'll first go back and look at in 2010, where VMware and BlackBerry were developing. They had the top 2 hypervisors for mobile devices, which was used for security and protecting personal information. But it does add another layer of complexity for forensic investigations. There's also the complexity of the separating personal information from business-related data. Since a lot of companies now are allowing the bring your own devices practices, it makes it more difficult. Also, the Internet of Things brought a new challenge to the forensic field because we have so many devices that are connected to the internet. It's really more than we have people. That number is expected to reach 50 billion devices connected to the internet in the next few decades. So from the Internet of Things, we evolved to the Internet of Everything, to the Internet of Anything. So we look at this, when we go through this evolution, the Internet of Everything, that added features that aren't tangible but widespread on the internet, such as Google search engine and YouTube. So we move to the Internet of anything. That includes the cars, our homes, our pets, any kind of application that makes all of these live together. And this also includes 5G smart devices, 5G mobile networks, as they're gaining momentum. They include, enhanced mobile broadband. They got ultra reliable, low latency communications, and also massive machine top communications through 5G. It also introduces new challenges with 5G to digital forensics, because now we have people-to-device communications, device-to-device communications, or device-to-cloud communications that would need to be investigated. We also need to look into with the Internet of Anything in our digital forensic, mobile forensics, including wearable computers, and also vehicle systems forensics, which that will address the parts that have sensors in cars. You think about a car, these sensors now in cars include, say, your light beams, your GPS, your power steering. I mean, there's all kinds of sensors in cars that you may have to perform forensics on. All right, so this is wrapping up chapter 12, talking about mobile device forensics. It's an ever-changing field. It's one that's becoming more important because more and more devices are growing in popularity. More and more people are using them. Make sure that if you do physically acquire a device, you need to isolate it so you stop the new messages from coming in. Once again, the Internet of Things is also increasing our challenge to collect the information in our forensics investigation.